Bismillahirrahmanirrahim. In this tutorial, we will try to understand why exactly half-filled and completely filled orbitals are more stable as compared to other electronic configuration. Firstly, here we can see that these are exactly half-filled electronic configurations of s orbital, p orbital, d orbital, and f orbital. And here these are completely filled electronic configurations of s orbital, p orbital, d orbital, and f orbital. Now we will try to understand what's the reason behind the stability of exactly half-filled orbitals and completely filled orbitals. Number one is symmetrical distribution. As we can see that in these states, that is exactly half-filled state and completely filled state, electrons are symmetrically distributed. That's lead to the stability of these two states, that is exactly half-filled state and completely filled state. Another factor that contribute to the stability of exactly half-filled and completely filled orbital is the exchange energy. Now, what is the exchange energy? It is basically amount of energy that is released when electron with the same spin in degenerate orbitals exchange their position. It means that electron present in these degenerate orbital, they will exchange their positions, and during this exchange process the amount of energy will release. And we also know that energy and stability are reversible phenomena. It means that this release of energy will lead to the stability of these electronic configuration states. Now, higher the exchange number, higher will be the stability. Let's try to understand this phenomena with example. Here all possible electronic configurations of d orbital are mentioned. Now for d1 state, we can see that here is only one electron is present. It means that its exchange number is 0 because there is no another electron with which it can exchange its position. That's why its exchange number is 0. And if we talk about its symmetry, it is unsymmetrical distribution. That's why d1 state is unstable. Now if we look for d2 state, here we can see that there are two electrons are present, so exchange is possible. It means that this electron can exchange its position with this electron, so exchange number for this electron is 1. Now if we look for this electron, as we can see that all other three degenerate orbitals are empty. It means that exchange number for this electron is 0. So overall we can say that exchange number for d2 state is 1. And if we talk about the symmetry, so it is unsymmetrical. That's why this state is also unstable. Now if we look for d3 state, here we can see that 3 electrons. Now the exchange number for this electron, it means that this electron can exchange its position with this electron, also exchange its position with this electron. So exchange number for this electron is 2. Now if we look at this electron, it can exchange its position with this electron. So exchange number for this state is 1. Now here we can see that remaining two degenerate orbitals are empty. So exchange number for this electron will be 0. So overall exchange number is 3. And if we look about the symmetry, here we can see that electrons are unsymmetrical distributed. So d3 state will also unstable state. Now if we look for d4 state, here we can see that this electron can exchange its position with this electron, also can exchange its position with this electron and with this electron. It means that exchange number for this electron is 3. Now if we look at this electron, so exchange number for this state is 1 and 2. And exchange number for this electron is 1. And exchange number for this electron is 0. So overall exchange number is 6. And if we look about the symmetry, here we can see that electrons are unsymmetrically distributed. It means that d4 state is also unstable state. Now d5 state, here exchange number for this electron is 1, 2, 3 and 4. And exchange number for this electron is 1, 2 and 3. And similarly exchange number for this electron is 1 and 2. And exchange number for this electron is exchange number for this electron is 1. And we can see that overall exchange number is 4 plus 3 plus 2 plus 1, that is 10. Here the exchange number is 10, and we can also see that electrons are symmetrically distributed. Now for d6 state, here this electron can exchange its position with this electron, similarly with this electron, and with this electron, it means that its exchange number is 4. 1, 2, 3 and 4. And exchange number for this electron will be 1, 2 and 3. And exchange number for this electron, it means it can exchange its position with this electron and with this electron. So exchange number for this electron is 2. Now the exchange number for this electron is 1. So overall exchange number is 10. Here we can see that exchange number for state d5 and d6 is exactly same, but d5 state is stable state while d6 state is unstable state. The reason behind it is symmetrical distribution. As we can see that in d5 state electrons are symmetrically distributed, while in d6 state electrons are not symmetrically distributed. That's why d6 state is unstable state, although its exchange number is equal to that of d5 state. Now if we look for d7, here we can see that and here we can also see that an electron with opposite spin is present, but the exchange number for this electron is 0, because in the definition we already have mentioned that electron can only exchange their position with the same spin electron. So here is only one electron with opposite spin, so its exchange number will be 0. Now for d7 state, exchange number for this electron is 1, 2, 3, 4. And similarly exchange number for this electron is 3, exchange number for this electron is 2, exchange number for this electron is 1. Now if we look here, two electrons with opposite spin are also present. It means that this electron can exchange its position with this electron. So one more exchange number is present, but there is no another opposite spin electron in remaining orbital, so exchange number for this electron will be 0. So overall exchange number is 11. Here we can see that exchange number for d7 state 11 is more than d5 state, but still d5 state is more stable as compared to d stable state, because we already mentioned that there are basically two factors that contribute to the stability. Number one is the symmetrical distribution and number two is the exchange energy. Although in d7 state exchange number is high, but here we can see that electrons are unsymmetrically distributed. That's why this state is unstable as compared to d5 state. Similarly, we can see that in d7 state exchange number is for this electron is 1, 2, 3 and 4. Similarly for this electron is 3, for this electron is 2 and for this electron is 1. Now here we can see that 3 electrons with opposite spins are also present. It means that exchange number for this electron is 1 and 2. And exchange number for this electron is 1. And exchange number for this electron is 0, as in these two orbitals or degenerate orbitals no electron with opposite spin is present. Here again the same reason, although d8 state exchange number is higher as compared to d5, but due to unsymmetrical distribution it is unstable state as compared to d5 state. Now for d9 state exactly same phenomena will be repeated. Here exchange number for this electron is 1, 2, 3 and 4. And exchange number for this electron is 3, exchange number for this electron is 2, exchange number for this electron is 1. And if we look for opposite spin, we can see that exchange number for this electron is 1, 2 and 3. And exchange number for this electron will be 2, exchange number for this electron will be 1. So overall exchange number is 16. But again it is unstable state because no symmetry is present. Now if we look for d10 state, here we can see that exchange number is for this electron is 1, 2, 3 and 4. Similarly exchange number for this electron is 1, 2 and 3. And exchange number for this electron will be 2, exchange number for this electron will be 1. Similarly exchange number for opposite spin is 4 plus 3 plus 2 plus 1, and overall exchange number is 20. Here exchange number is higher than all other possible states, and also electrons are symmetrically distributed. So now we can simply say that D5 state and D10 state that are exactly half filled state and completely filled states are more stable as compared to other states due to two phenomena. Their exchange number is high. Number 2, electrons are symmetrically distributed in these two states. Hopefully this tutorial will prove helpful for you. Thank you so much.